Then we're recording. Okay, so we're going to be doing sequences. And basically a sequence is like a listing of numbers. And that has like, that you can tell there's a rule that works with it. That's what it is. So that's essentially what it is. Go ahead and turn this off. Okay, so for instance, you might have the following number here: 1, 4, 9, 16, and 25. So you could see something there, right? Like what is like the rule here that you would use? So the first number will be 1, second number is 4. What does it seem like it is? So each one of those numbers is called a term, right? So look, one, like it's not so obvious, right?
Teachers and students, please pardon this interruption. All students performing at the lip sync battle, please report to the auditorium. All students performing at the lip sync battle, please report to the auditorium. Thank you.
Like, obviously it feels like look, 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. You see it? I mean, sometimes you look at it and you don't see the rule very well. You see that, right? So makes sense. Let's see if we can look at another one. I'm gonna give you 1/2, 2/3, 3/4, 4/5, 5/6. What rule does it look like it's there in that particular sequence? Well, we're just increasing the denominator by what? By 1, right? Does that make sense? Like, if you look at it, depending on which one you're at, you're just increasing the denominator by 1. You're also increasing the numerator by 1, right? So they might say, and this is what they like doing. They might say the following. You might state the first one. Excuse me 1 second. So I'm scratching myself. I have this Achilles tendon issue here. I don't know. It's gonna take at least a month or 2 to heal. Let's look at it. You're increasing it by 1. So you could, the way they like doing this is it might say use of R is R plus R plus 1. And obviously you would have to state the first one. You would say, well, you say use of 1 is equal to half. And then what you say is, okay, use of 1 is half. So use of 2 equals 2 over 2 plus 1. Right? And then use of 3 will be 3 over 3 plus 1. You see that? And use of 4 equals 4 over 4 plus 1. And defining something like this, we say this is an inductive definition. That's what we say. And again, this is not something that we're used to doing. This is not something that we're used to doing. It feels really artificial. So what I want to do is I want to go ahead and just practice some of this. So if you turn to page 115, if you have the book, if not, just we're on page 115. This is section 8A. I might give you something like this. I might give you use of 1 equals to 7, and use of r plus 1 equals use of r plus 7. And I ask you to write the first 5 terms. Let me go ahead and scroll that up. So what is it saying? So what's the first term gonna be? What's its first term gonna be? 7. Now, what does it say? Let's say you want to find use of 2. So use of 1 is 7. But let's say you want to find use of 2, you say r equals to 1. 1 plus 1 is equal to use of 1 plus 7. So use of 2 just equal use of 1 plus 7. Therefore, use of 2 must equal 7 plus 7, which is 14. So the next one will be 14. Okay, so you saw this here. It says use of r plus 1 equals to use of r plus 7. So I wrote, well, when r equals to 1, we have use of 1 plus 1. Perhaps I should do this a little bit more pretty. Right? So this is 1. 1 plus 1. That's equal to use the r here became use of 1 plus 7. If use of 2 equals use of 1 plus 7, use of 1 is 7, 7 plus 7 is 14. So now I know the second term is 14. Now for r equals to 2, use of 2 plus 1 equals use of 2 plus 7. Use of 3, therefore, is use of 2 plus 7. But use of 2 is 14, and 14 plus 7 is 21. So now you know that you're going to add 7 to 14. And that means the next one, if we were to continue that, we can see that's just going to be 7 more. And the next one will be 7 more. And that completes the sequence. So it seems difficult, but it's not difficult. See, try to do this one on your own for a few seconds or a few minutes. They want you to find the first 5 terms. And I'll pick a slightly more difficult one. And then we'll work on some of the other things. I remember this quite well. Then I have to look the workout later. So think about this. Set it up like the previous one. Because I see some people just waiting for me to do it. Okay, so what's the first term? 13, we know that. So now we go, okay, if R equals to 1, you have that U's of 1 plus 1 equals U's of 1 minus 5. So that's U's of 2 equals U's of 1 minus 5. So U's of 2 must equal 13 minus 5. 13 minus 5 is equal to 8. So now we have 8. Now you continue. R equals to 2. U's of 2 plus 1 equals U's of 2 minus 5. You could tell now what the rule is. I mean, you could see it. It's just repeating the same thing that we did in the previous one. U's of 2 is simply just 8 minus 5. And you're just going to subtract. You're just going to subtract. So 8 minus 5 is 3. 3 minus 5 is negative 2. 2 minus 5 is negative 7. And those are the 5 terms of this particular sequence defined inductively that way. That's how they're defined inductively. I shouldn't have put 2 there, but whatever. This actually was, this was 1A, and this was 1B. Let's see if I can pick a slightly more interesting one. And they're not that interesting, you know, it's just practice. So 1F says, U's of 1 equals to 1, and now U's of R plus 1 equals to U's of R squared plus 3. I'll scroll it up. So what's our first term? So the first term is definitely 1. I'm trying to make it look pretty. So we have 1. So now R equals to 1. That's U's of 1 plus 1 equals to U's of 1 squared plus 3. So U's of 2, therefore, is U's of 1 squared plus 3. So U's of 2 equals to 1 squared plus 3, which is equal to 4. So now we have 4. I got a feeling the next one's going to be, you just do 4 squared plus 3, which is 16 plus 3, which should be 19. Let's write it out. R's of 2 is U's of 2 plus 1 equals to U's of 2 squared plus 3. So that's U's of 3 must equal oh my gosh, look what happened. Let me zoom in. It would be U's of 2 squared plus 3. So that's U's of 3 equals to 4 squared plus 3. So that's going to equal to 16 plus 3, which equals to 19. And so now you would know that the next one has to be And you can see it's gonna be 19 squared plus 3. Now I don't know what 19 squared is. I'll just use my calculator. It's 361 plus 3, so we're at 364. And then 364 squared, right? Square it, and then add 3, some ridiculous number there, 132,499. And those are your first 5 terms.
Where did you get the 4?
Okay, so do you see where we got the 4? The first 4, 1 and 4. So look, when we did this here, so we're here, right? You see that, right? What's the use of 1? It's 1. 1 squared plus 3 is what? 4. You see it? Okay. All right, so far so good. Okay. But now, what if I, instead of giving you the inductive definition, I ask you to find the inductive definition? So let's go to 2A and take a look at it. We got 2, 4, 6, 8, and 10. And you now have to come up with an inductive definition. So let's do it. What's my first term? So use of 1 equals to 2. So could you tell me what use of r plus 1 is? Use of r plus 1 should be use of r times what? Is it times 2? Well, let's see if it works. 2 times 2 is 4, but 4 times 2 is 6. 4 times 2 is 6. So what is it, multiply or is it plus? There you go. Yeah. You see how it works? So the first one is 2. So when we put r equals to 1, it's use of 2. And then you have use of 2 equals use of 1 plus 2. Well, that's 2 plus 2, which is 4. The next one will be 4 plus 2, which is 6. And then 6 plus 2, which is 8. And 8 plus 2, which is 10. So does that inductive definition feel like it's going to work? Okay. Let's do 2B. Let's say you have 11, 9, 7, 5, 3. So what is my first term? Now, what does it look like it's doing? It's subtracting 2, 2, 2. It's definitely subtracting 2. So give me a definition. Use of r plus 1 must equal use of r minus 2. Now let's be clear. So it's gonna, so you have 11, 11 minus 2, boom. And then you have 9, 9 minus 2, 7, and so on. Does that make sense? Okay, let's see if there's a more interesting one. What if I give you the following? 1/3, 1/9, 1/27, 1/28. Definitely looks like we're multiplying the denominator by 3. Oh wait, I must have written the last one wrong. You see, because the pattern broke down there. 81, sorry. I don't know how I end up writing 28 instead of 81. So what does it look like there? So what's my first term? 1/3. So use of r plus 1 must equal what? How would you write this? Okay, you're saying you are what? Okay, so if you write use of r, that's fine. Times 1/3. Would that work? I think it will. So let's see. All right, so R equals to 1. You have use of 1 plus 1 equals to use of 1 times 1/3. So use of 2 must equal use of 1 times 1/3, right? Which is 1/9. Okay, works for that one. Now let's do the next one. R equals to 2. So we have use of 2 plus 1, which equals use of 2 times 1/3. Use of 2 is 1/9 times 1/3, indeed equals 1/27. That is a good inductive definition. Okay, let's try another one. Let's try another one. How about this one here? We have a to the third, b to the second. A to the second over b, then we have a, then we have b, dot, 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 dot. Let me scroll it up. Everybody can see. It is a refrigerator in this room. So think about what's happening there.
The exponent is subtracting.
Yes, the exponents are subtracting, but one of them is subtracting and one of them seems to be adding. Well, I mean, I shouldn't have put it that way, but I'm just trying to make this look pretty. Oh, wait, I messed up there. Of course. Okay, good. So then this one goes here. Is it a little bit harder? You want to play around with it? How would if you got this on a bro, I messed up again. I can't believe this. It's just confusing me. Give me 1 second. Let me see. I'm just trying to make these lines here. Only if you're careful. All right, so here I did this one and this one gets lined under it. I just and then this one I did this and then it gets lines under it. And then this one's here and it gets lines under it. Yeah, I think I got it this time. This one's here. Okay, good. So, all right, so let's take a look at what happened between the first term and the second term. It looks like to me that I multiply by b over a. So if you take a to the third over b squared and you multiply by b over a, you end up with a to the second over b. Because one of this b cancels out that b. You see that? Does that make sense? And then I take a to the second and I multiply it again by b over a, the b will cancel, but we're left with an a. Does that make sense? And now we take a and we multiply it by b over a, the a cancels and we're left with b. It's called imagination. It's called you have to be clever. And the more you practice these things and the more you think about it, the more you can put together the puzzle to make it happen. But do you see that? So we have use of 1 is a to the third, b to the second. So use of r plus 1 equals to use of r times b over a. And that's the inductive definition of this. Seems to be, to me at least. Fair enough, guys and gals? Pupils? All right, so let me go ahead and make a line here. All right, so now I'll, the way I'm teaching you this section is not by just doing examples, because I think when you visually see it, it's really good. You know, when you visually see it. So now we're going to look at problem number 3 in this section, 3A. And it says, write down the first 5 terms of each sequence and give an inductive definition for it. So in this case, 3A, they say that use of R equals 2R plus 3. Right? So in this case, it says, write down the first 5 terms of each sequence. So let's go. Use of 1 is going to equal to, yeah, I just, no.
Mr. Can I use a bathroom?
Only be careful. So use of 1 equal to 2 times 1 plus 3, right? So use of 1, so this is a formula they give you. So it's 2 times 1 plus 3, so that's 2 plus 3, which is 5. Use of 2 is 2 times 2 plus 3. So that's 4 plus 3, which is 7. Use of 3 equals 2. 2 times 3 plus 3. That's 6 plus 3, which is 9. Use of 4 is 2 times 4 plus 3. That's 8 plus 3, which is 11. Use of 5 equals 2 times 5 plus 3, which equals 10 plus 3, which is 13. So I've written now the first 5 terms of my sequence. I'm going to go ahead and do this in blue. 5, comma, 7, comma, 9, comma, 11, comma, 13. It looks like we're adding 2. So my inductive definition would be use of 1 equals to 5, use of R plus 1 equals use of R plus 2, and you're done. And you're done. Don't you feel cool that you're writing your notes on your iPad? And these other people here writing on paper. Paper. It is, you know, if I had to be a student using this, I would feel really weird. Same thing with reading. I'm starting to get used to reading electronically, but I really like books.
I don't
now.
like reading electronically because then like my eyes like get straight and it feels like I'm reading a fake book.
A fake, it is a fake book, but I'm starting to get used to it. Starting to. Okay, so now let me give you another one, and let's see if you could do it. So this is gonna be 3E, which looks disgusting to me, but let's see if we can do it. It says use of R equals 2 times 3 to the R. So let's do that. See if we can do it. So get the first 5 terms. Get the first 5 terms, and then once you get those terms defined, get the inductive definition.
Yeah, because, right? Is that an X or times?
Times. That means times. So the easy part is just going. Okay. So use of 1 equals 2 times 3 to the first. So that's 6. Use of 2 equals 2 times 3 to the second. That's 18. Use of 3 equals 2 times 3 to the third. That's 27 times 2, 54. Use of 4 equals 2 times 3 to the fourth. That's 3 times 3, 27. 81 times 2 is 162. 81 times 2, 162. And the last one will be use of 5 equals 2 times 3 to the fifth. Well, 81 times 3 is 243, and 243 times 2 is 6, 8, 46. So now I'll do this in blue. We have 6, 18, 54, 162, 46. So use of 1 is 6. Therefore, use of R plus 1 equals, what does it look like is happening there? 6 times 3 is 18. What about 18 times 3? Yeah, so therefore you're going to say 3 times use of R. Does that make sense? Pretty easy, right? So now I want to go ahead and move to number 4. And we still got plenty of time in class. So I hope to get, I mean, I won't be done with section 8, but I'm starting to get close to it. So number 4 says, you know, you have A for A. We have 9, 8, 7, and 6. But they don't want, I mean, if you were to do an inductive definition for this, what would you do? Now that we've done a few of them practicing, what would you do? What would be use of 1? 9. And what's use of R plus 1? What would it be? What? Yeah, super easy. But now, could you make a formula for this? Could you make a formula instead? Where I say use of R. That would be the formula. Oh, yeah. So could we find a formula where you would put 1 in there for the first term and you get 9, and you put 2 and then you get 8, and you put 3 and then you get 7, and so on. Could you figure out a formula for that? Okay, so let me see. Look, for instance, let's write this. Use of 1 is 9. Agreed? Okay. Use of 2 is 9 minus 1. Agreed? Use of 3 is 9 minus 1 minus 1. Use of 4 is 9 minus 1 minus 1 minus 1. Use of 5 is 9 minus 1 minus 1 minus 1 minus 1. Would that work? What do you notice? Well, how many ones do I have for use of 1? How many ones do I have here? Minus none, right? How many ones do I have here for use of 2? And 3? And 4? And 5? So let's agree that you're taking 9, you're subtracting 1 times r minus 1. So look at this. Let's see if it works. If you put in 1, you're going to get a 0 there for r minus 1. So you just get 9. If you put 2, you got 2 minus 1, which is 1, and 1 times negative 1 is just negative 1, 9 minus 1. If you put in 3, 3 minus 1 is 2. And 2 times negative 1 is negative 2, 9 minus 2 is 7. Do you see that? You have to follow along. If you can't follow along, I can't tell. But we would simplify his formula. We write as 9 minus r plus 1. You see that? So it's really 10 minus r. So use of r. So the final formula here would be use of r is 10 minus r. Let's see if it works. If I put a 1 in there, I get a 9. If I put a 2 in there, I get an 8. If I put a 3 in there, I get a 7. If I put a 4 in there, I get a 6. You see it? It's 10 minus r. But do you see the difference between the inductive definition and the formula? And they both give you the same thing. But we don't do this oftenly. And there's several ways. And sometimes you have to be clever. Sometimes you have to be clever. You don't see it. Like, it's just what it is. Do you want to try another one? All right, let's see if you're clever. So 4C. 4C gives you 4, 7, 12, 19. Find a formula for that. It's cold in this room. So 4 plus 3 is 7. 7 plus 5. Oh, you can't see it. I'm so sorry. 4 plus 7 plus 12 plus 9. So first you added 3, then you add 5, then you add 7. So how on earth are you supposed to reconcile that if it changes that? So again, either you're clever about this, or you have to figure out how you can find patterns within the numbers. So you're saying, oh, here it's between 7, it's plus 3, between the 12, it's plus 5, and between the 19, it's plus 7. Okay, so this is just to be clear, this is right here where r. So if this is r values, this is 1, this is 2, and this is 3, and this is 4 r value, right? So I mean, so tell me the formula. All right, so this is how I begin these when I'm stuck, when I'm not sure, when I'm looking at it and I can't obviously see the formula. I mean, I think I could possibly play around with it, but what I do is I go, okay. And I normally use different letters. I don't like using U. I like using A's of 1 equals to 4. A's of 2 equals to 4 plus 3. A's of 3 equals to 4 plus 3 plus 5. Okay. A's of 4 equals to 4 plus 3 plus 5 plus what? 7. So we do notice that we have 4 everywhere. We notice we have a 3, 3, and 3, but now we have 5. But isn't 5, and this is me thinking out loud, isn't 5 really like just 3 plus 2? And isn't 7 really 5 plus 2? And isn't these 5s really 3 plus 2? So shouldn't I just say, okay, I'll write this in red. Isn't this 4 plus 3 plus 3 plus 2 plus 3 plus 2 plus 2? And then if I start arranging these, I would notice now that this one here was 4 plus 1, 2, 3, 3 threes. And then we have 1, 2, 3 twos as well. I don't know where I'm going with this. Right? Let's see this one. This one has, I don't like that pattern because it looks weird to me. Something's missing. So let me make sure I got everything right. 3 plus 2, 3 plus 2, 3. Okay. And then this one here was 3 plus 2 plus 3. Did I get all my 3s there? All right, that's the best I can do. I don't see a pattern there. Maybe I'm wasting my time. Because you would want to see a direct pattern, wouldn't you? But I don't see it. Maybe I miswrote something. No, I didn't. No, I didn't, because this goes to this 7 here is here and here, and this is here and here, and this is here and this is here, and it's correct. And there's 1, 2, 3s, and there's 1, 2, 3 2s, and it's right. And if you add it all together, you're gonna get those numbers. If you take 3 plus 3 plus 3, you get 9, and 9 plus 6 is 15, plus 4 is 19, and that's correct. Anybody clever? No. No. Well, I'm looking at it right now, and I'm thinking to myself, okay, I know for a fact that I'm the 3, the first 3 I'm adding, the next one I add, when I go to 2, I add 2 more to the 3, right? So how would you define that? No one? No one can help me here? No one? Come on, guys. Anybody clever in the class?
No.
All right, so let's play around with it then. Let's say I were doing this problem. I'm stuck, right? I'm stuck. Let me scroll this. I'll do it here on the side. Should I do it on the side? Yeah, I can do it on the side. All right, so let's say I'm stuck on the problem. I go, okay, for r equals to 1, so a's of 1, you're gonna have 4, right? But like, how can I make it just be 4? Because I know a's of 2 is 7. So I might say, okay, so that's what if I take 4 plus 3, but I can only have it happen once, right? So this R here, something over here with the R has to be happening just once, right? So you would put R minus 1, right? So you go, okay, does that work? 4 plus 3 times 2 minus 1, 4 plus 3 times 1, that's 4 plus 3, which is 7. Okay, it works. Then you say, okay, does that formula make sense now when I increase? Because when I go to A's of 3 is 12, you get 4 plus 3 times 3 minus 1, 4 plus 3 times 2, which is 4 plus 6 is 10. It doesn't work. So this formula is no good. It doesn't work. Okay? Does not work. So let's revisit the patterns that we have. Let's try something different. So we got 4 plus 3 here, but here we have 4 plus 3 plus 3 plus 2. We know that that's going to be what? What's 6 plus 2? All right, let's go. So you see the second one where we had, so this one was 4, this one was 7, and this one was what? 12, right? 4 plus 3 is 7, 7 plus 3 is 10. So really, isn't this 4 plus 3 plus 3 is 6 plus 2 is 8? So this one here really was 4 plus 8. And this one here was 4 plus, well, 5 plus 3 is 8, plus 5 is 13, plus 2 is 15. So it's 4 plus 15. Any pattern there? Well, I know it's adding by 4, but okay, it's okay, it's okay. So look at this. Okay, what's 2 squared? And what's 4 minus 1? Good. How about what's 3 squared? And 9 minus 1? How about 4 squared? And what's 16 minus 1? You see it? That's a really rude way. It's super rude because you can't see it. It would take you maybe. So now you know this is going to be 4 plus n squared minus 1. Right? Assuming we're saying a's of n like this. Right? Because when you put 1 in there, you get 0, which is 4. When you put in 2 there, you get, and then obviously you're going to multiply this obviously by, no, that's it. That's what you do. That's it. That's the answer.
So you just write like the formula.
What? Say that again?
Like you write the formula.
Yeah, but this formula doesn't end that way. This formula, all right. So let's make sure it works though. Look, pick 4 for it. What's 4 squared minus 1? 15. 15 plus 4 is 19. That's right. Let's put a 3. 3 squared is 9. 9 minus 1 is 8. 8 plus 4 is 12. 2 squared. 4 minus 1 is 3. 3 plus 4, 7. 1. 1 squared minus 1 is 0. 4 plus 0 is 0. And it works. And then to simplify it, we would just say this is n squared. Look at this. This is n squared plus 3. If you put a 1 in there, it comes out to 4. If you put a 2 in there, 2 squared, 4 plus 3. It works. 3 in there, 3 squared plus 3, it works. 4 squared plus 3, it works. And you're like, of course it works. Of course it works because you just saw the answer. But could you have seen? The answer is probably, it's very hard to see. Now, there's probably ways of parsing this out, that sequence where you could see it, but I'm not interested in doing this now. But you see what I'm saying, right?
I see it after.
Okay, that's okay. That's okay. That's okay. But do you see how some of these questions you can get stuck like that? Okay, let's now, I'll wrap up the class with the final thing, two other things. But yeah, some of these are more challenging than others. That one looks simple, but it was challenging. Some people say, oh, I saw it from the beginning. I'm like, no, you didn't. No, you didn't. It's all right, so I'm preparing that. Okay. Scroll back up. Oh, it's cold in this room, man. It has to be. It's like it's almost making fun. It would be nice if you were. All right. So the next thing we're doing is we're doing the triangle number sequence. Triangle number sequence. And it's super easy. And it's also maybe a little profound. So let's say you have this here, right? That's 1. But now you go 1 plus 2, basically. Right? And then you have maybe, I'll do it like this. You have 1, 1, 2. So maybe I should do it like this, just to be consistent. But 2, 3. You grow it by 1. 1, 2, and 3. And then you go 1, 2, 3, and 4. And you keep on doing this. This is called the triangle number sequence. So basically it's this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so on and so on. So you have the triangle number sequence, which seems kind of dumb to name it that, but it is what it is. And then I ask you, well, can you add up those 10 numbers? And you're like, of course I can, because I'm smart. And I tell you, yeah, I know you can, because you come up with a formula. And here's something interesting about this. One plus 10 is what? 11. And what's 9 plus 2? 11. And how about 8 plus 3? And how about 7 plus 4? And how about 6 plus 5? 11, right? So if you add up all those numbers, and I know I kind of messed that up there, but what's the answer to 1? Adding 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. It should be what? It should be 5 times 11, which is 55. Look at that. How wonderful. Now, I'll go back. Okay, here's what I want you to do now. I want you to take your calculator and I want you to add 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 plus 9 plus 10. Add them. You got 55? Wow. I got 55 too, but I use a different method. So the way I did it is a little bit different from yours. I realized that if I took 10 plus 1, I got 11.
Yeah, I got that part, but you added it 5 times, and then 11 times 5 is 55. No, I know I get it, but why did you get the 5?
Okay, how many 11s do I have now? 2. How many 11s do I have now? How many 11s do I have now? How many 11s do I have now? It's okay. 11 times 5 times 11. 5 times. So if you were to come up with a formula for this, what would the formula be? What's half? So how many numbers do we have here? How many numbers did we have here in total? How many numbers did we have here? 1 through 10. Yeah, 1 through 10. How many numbers were there? How many numbers are here? How many numbers are there? How many numbers are there? Don't look at this. How many numbers are there? Do you see that 5? What's 10 divided by 2?
5.
So I can say, okay, there's 10 numbers, 10 divided by 2. And how can I get an 11? I can take 10 plus 11, right? Plus 1, sorry. So that's, I could say maybe my formula for adding these numbers together would be you take the amount of numbers you have, you divide by 2, all right? And then you take those numbers and add 1 to it. So let's test this. I want to test this because I want to test this formula I just made up. I know you don't see it because I moved it. I take 10 divided by 2, which is 5, and then times 10 plus 1, 11. So maybe my formula is n divided by 2 times n plus 1. So this should work for, let's test it with 8 numbers. Do you want to test it with 8 numbers? Let's go ahead and test it. 1, 2, 3, 4, 5, 6, 7, 8. So this is a triangle number series, or just sequence, sorry. And we have 8 numbers. So 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. 10 plus 5 is 15. 15 plus 6 is 21. 21 plus 7 is 28. And 28 plus 8 is 36. I should get 36, right? So let me go ahead and verify that if we take 8 plus 1, we have 9. 7 plus 2, we have 9. 6 plus 3, we have 9. And 5 plus 4, we have 9. So it's 36, right? So we go back to our formula. How many numbers did we start with? We had 8. 8 divided by 2, right? We're looking at this formula here, times 8 plus 1. 8 divided by 2 is 4. 8 plus 1 is 9. 9 times 4 is 36. Does the formula work? Yes, it does. However, nobody asked me to test it for an odd amount of numbers. See, I picked an even amount of numbers on purpose, because what happens when we do an odd amount of numbers is we're left with the middle one, right? And that's a catch. So maybe our formula doesn't work all the time. Maybe sometimes it works, sometimes it doesn't, but we're going to check for odd amount of numbers. So let's just pick 9. We're going to do 9 numbers. 9 numbers in the, for the triangle number sequence. That means that each number, we start at 1 and we increment each one by 1. Because 2 is just a fancy way of writing 1 plus 1, you know? Right? So we have 9 numbers there. So first of all, let me just check this here for a second. 9 plus 1 is 10. 8 plus 2 is 10. 7 plus 3, 10. 6 plus 4, 10. And then we have a 5 left over. Oh, man. So this is really 4 times 10 plus 5. So it is 45, but that doesn't look like the formula before, right? So how could we get it? How many numbers do we have here? We have how many numbers? 9. So I can get 10 by taking 9 plus 1. How can I get a 4? How about 9 minus 1 divided by 2? Okay, no worries. I can work from outside. So 9 minus 1 divided by 2 times 9 plus 1. And then how will we get the 5? Wouldn't you do 9 plus 1 divided by 2? Right? That formula looks completely different. But think about it this way. What if we want n minus 1 divided by 2 times n plus 1 plus n plus 1 divided by 2? I mean, that looks different, but is it different? Let's see. So, can we add those together? Yes, we can have n plus 1 times n, plus n minus 1 times n plus 1 all divided by 2. But if we did that, that's funny.
Thank you, boss.
No problem. So now we go ahead and do that. And what you see here is you can see that you can factor out an n plus 1 from there. Can't you? Let's see. Ay, coño. My armpit itches. Okay, so you have n plus 1 times 1 minus, plus, n minus 1. And when you finish fixing that, let me make that prettier. Do you see what I did there, guys? That's the important part. I factored out this here. I pulled it out and I'm like, okay, n plus 1 times 1 will give me that. And n plus 1 times n minus 1 will give me this. And then when I simplify this here in the middle, you're left with n plus 1 times n divided by 2, which is the same formula as we got above. That's the same. In other words, it didn't matter. It's the same one. And in other words, if we would have started this question 9, and you would have said, Mr. Acosta, I have nine numbers in a triangle number sequence starting from 1, you go, oh, well, that's 9 plus 1 times 9 divided by 2. Yes, that's 10 times 9, that's 90. 90 divided by 2 is 45. You like that? 10 times 9 divided by 2 is 45. So that's 90 divided by 2 is 45. And would it have mattered if it's even or odd? The formula will be, if you have a triangle number sequence, the sum of the triangle number sequence, and I guess they actually use this letter here, T's of n or T's of r, is n divided by 2 times n plus 1. They actually write it differently, but that's the formula. That will tell you what it adds up to. That will tell you what it adds up to. Does that make sense? We haven't done much today. All we've done is discuss inductive definition. We discussed how to do the formula. Sometimes you have to be clever. And now we talked about the triangle number sequence and how the formula ends up being n half n times n plus 1. If you want to find out the sum of any particular triangle number sequence. Okay. So I'm going to go ahead. You see yourselves. Just a quick turn. Hey guys, did you know that we don't have to wear a mask anymore? Like you don't even have to opt in